Imagine handing over a 50 million line code base to a piece of software, and you just walk away. And then you come back 24 hours later and find a flawless, system-wide migration completely done.
Yeah, it sounds completely made up.
It really does, right. But that is not science fiction. That actually happened this month. So welcome to the deep dive. Just a really quick transparency note before we jump in here. The summary for today's discussion was created using Notebook LM, but I want to stress that everything we are unpacking today is based entirely on actual public sources from a massive June 2026 industry update.
Right. Actual data.
Exactly. Our mission today is to cut through all that noise and deliver the most critical insights specifically for you. So the cloud experts, the cybersecurity architects, the AI and ML professionals who are out there actually building and defending this infrastructure.
And the core theme really connecting all these sources today is that we have officially moved past this era of AI just acting as a helpful assistant. We are firmly, and I mean firmly, into the era of AI as an autonomous agent.
Right. It's a whole new ballgame.
It is. And that requires a total reimagining of the cloud infrastructure that powers it and, well, the cybersecurity frameworks defending it.
Yeah, I want to start by looking at what this technology is actually doing right now because, honestly, the capabilities are staggering. Anthropic just launched their new, what they call Mythos class architecture.
The big one.
Yeah. They announced Claude Fable 5, which is generally available now, and Claude Mythos 5, which is in a trusted access preview called Project Glasswing.
And this architecture, it represents a really serious paradigm shift in long horizon engineering autonomy.
And on horizon being the key word there.
Exactly. We aren't just talking about generating like a few lines of boilerplate code anymore. We are talking about persistent, goal-oriented execution that runs over days or even weeks.
Yeah, and the stats in this report are just wild. I mentioned the 50 million line Ruby repository migration that executed in a single day.
Which is insane.
It is. And the same architecture autonomously generated novel molecular biology hypotheses that were actually corroborated by independent lab findings later. Wow.
But the one that really stopped me in my tracks, it completed the game Pokemon Fire Red from raw screenshots with zero navigation scaffolding.
Yeah, that's the one.
I need to stop and ask about that specific mechanism.
Yeah.
Because I'm used to reinforcement learning models relying on heavily structured APIs, right? Where the game basically feeds the AI the exact, coordinates of every single object in the environment. How does it play a game with zero scaffolding?
Well, so that detail is actually the clearest indicator of how advanced this vision action loop has really become. The model isn't being spoon-fed a structured data array of the game state at all.
So it's just flying blind?
Not blind, it's looking at a grid of raw pixels.
Wait, really? Just the pixels on the screen?
Just the pixels. It has to derive the context itself. Like it has to figure out that a specific cluster of pixels is a wall and another cluster is a door.
Oh, wow.
Yeah, and then it makes a decision, executes a simulated button press, observes the resulting frame change, and just repeats that loop over hours of gameplay.
That's exhausting to even think about. Right. But Anthropic notes this is supported by a persistent file-based memory architecture. So it maintains state and context indefinitely, which, triples its performance stability over those long-running tasks compared to the older generations.
So it's evolved from this, eager intern who needs constant supervision to a senior staff engineer who literally never sleeps and remembers every single file they have ever read.
That's a great way to put it.
But, handing an autonomous AI the keys to a 50 million line enterprise code base sounds terrifying. How are engineering teams actually controlling a system that powerful?
Well, Anthropic anticipated that exact risk, which is why they simultaneously announced the general availability of managed agents. They basically fundamentally decoupled the system architecture.
Okay, decoupled how?
They separated the open-loop large language model from the closed-loop execution harness.
Oh, I see. So the thinker is separated from the doer.
Exactly. The open-loop LLM is the generative engine, right? It comes up with a migration strategy, but it cannot execute code directly.
Thank goodness.
Right. It passes those instructions to the closed-loop execution harness. So it's this integrated generator-evaluator architecture.
Okay.
It forces deterministic verification loops. So the execution harness runs the generated code in a heavily sandboxed environment. It checks the output against predefined boundary limits, and it actually enforces human-in-the-loop checkpoints before any side effects are committed to the main branch.
So you basically get clean, linearly auditable action logs.
Exactly.
So the AI can write the migration script for the Ruby repo, but the execution harness acts as this absolute firewall to ensure it doesn't, accidentally drop the production database in the process.
Precisely. And that connects perfectly to what Microsoft just moved to general availability, which is the SQL Model Context Protocol server, or MCP server.
Right, the MCP server.
Yeah, because the SQL MCP server solves a massive problem in enterprise AI deployment. It's an open standard architectural framework that allows these autonomous AI agents to safely inspect relational database schemas so they can discover metadata and fetch structural contexts. Previously, data engineers had to write these really fragile, custom data access APIs just so the LLM could even understand what the database looked like.
Which I imagine radically slashes hallucinations. Because instead of the model, guessing what your customer transaction table looks like based on its general training weights, it securely fetches the actual schema in real time.
Right. It grounds the model's logic in your actual enterprise data.
That makes so much sense.
And because it operates on Anthropic's open source model context protocol, AI teams can actually wrap these data fetching connections within Azure API management.
Good, nice.
Yeah, so you can observe the exact queries the agent is making, you can version the connections, and enforce strict identity-based security boundaries.
But there is a bottleneck here, isn't there? Because if the AI is smart enough to generate molecular biology hypotheses in seconds, and it's natively querying massive relational databases, it's going to starve if the data pipelines feeding it are still running at legacy speeds. I mean, the data engineering layer has to keep up.
Oh, absolutely.
Okay.
Which is exactly why Amazon EMR just announced the general availability of Apache Spark 4.0.
Right.
The performance leap there is substantial. We're talking workloads running up to 4.5 times faster than open source alternatives.
4.5 times. That's huge. They also introduced Spark Connect as part of this release, right? The documentation says it uses a gRPC-powered client-server architecture. But what does that actually mean for the developer sitting at their desk?
Well, it basically means they don't need to spin up a massive, heavy local cluster just to test data transformations anymore.
Oh, that's a relief.
Yeah, the gRPC architecture separates the client application from the execution engine. So your local laptop basically just acts as a lightweight remote control.
Got it.
You can build and debug PySpark transformations remotely right from your local IDE, and all the heavy lifting is executed instantly on the EMR cluster.
That makes the development cycle incredibly fast. But, the feature in Spark 4.0 that seems like the biggest deal for machine learning is the new variant data type.
Yes, the variant type is a game changer.
Because when dealing with IoT telemetry or highly unpredictable JSON inputs, data engineers usually have to build these incredibly fragile ETL pipelines to enforce strict schemas. And if a new field pops up in the JSON payload, well, the pipeline breaks.
Exactly. And the variant data type natively processes that evolving semi-structured data without having to predefine those schemas.
So it just handles it.
Yeah, it stores the data alongside its metadata dynamically. It completely removes a massive bottleneck in ML feature engineering. It just allows the data to flow into the training models, regardless of how the input structure shifts.
So if we look at what we have so far, we've got autonomous agents writing code. They're safely querying relational databases via open standards and processing massive data pipelines 4 times faster. But running all of this, that requires a fundamentally stronger, faster, and much more observable cloud foundation. We are essentially building a massive new engine for the enterprise here.
We are, and that engine requires an entirely new generation of silicon. So AWS just transitioned their Amazon EC2 M9G and M9GD general-purpose instances to general availability, and those are powered by their custom-designed AWS Graviton 5 processor.
Yeah, and the hardware specifications are just a massive leap. It is the first CPU in the AWS fleet to support PCIe Gen 6 and DDR5 8800 memory, right?
That's right.
It features a 5 times larger L3 cache than the Graviton 4, and it reduces intercore latency by like 33%. So in practical terms, that translates to up to 35% faster machine learning inference and web application execution.
Which is great. The compute speed is really impressive, but honestly, for cloud architects building multi-tenant environments, the architecture of the hypervisor is actually the most significant announcement. AWS has integrated what they call the Nitro Isolation Engine.
Okay, yes, I wanted to bring this up because the documentation claims the Nitro Isolation engine has mathematically proven security at the silicon level. And in an industry where calling something unhackable is usually a giant red flag, What does mathematically proven actually mean in this context?
Right, it sounds like marketing speak,
Yeah.
but it comes down to a process called formal verification.
Formal verification. Okay.
See, most security models rely on heuristic vulnerability scanning or software sandboxing, which is basically testing millions of known attack scenarios and seeing if anything breaks through.
Just throwing everything at the wall.
Right. But formal verification doesn't rely on testing scenarios at all. It uses mathematical proofs to define the absolute boundaries of the hardware and the microcode.
Wait, really?
Yeah, it mathematically guarantees that the logic of the isolation layer will behave exactly as specified under all possible conditions.
Oh, wow. So it is not testing to see if a breach is likely. It is proving structurally that a cross-tenant data leak or an execution boundary violation is, like, mathematically impossible at the hardware level.
Exactly, because when you have multi-tenant cloud environments running highly sensitive, autonomous AI workloads,
Like those agents writing code.
right, agents that are writing code and accessing proprietary databases.
Hmm.
When you have that, silicon-level virtual machine isolation isn't a luxury anymore. It is mandatory. The blast radius of a compromised autonomous agent is just far too high to trust a software-level isolation alone.
But even with mathematically proven silicon, managing a hardware fleet at this kind of scale requires absolute visibility. I mean, if an automated AI pipeline misfires, it can generate massive costs or cascading failures in seconds.
Oh, absolutely. And observability is shifting from reactive logging to dynamic platform streaming. Microsoft just announced the general availability of Azure Monitor Metrics Export.
Okay.
They are officially shifting away from legacy diagnostic settings and moving entirely to data collection rules, or DCRs.
And the primary advantage there is preserving dimensional fidelity, right?
Yes, exactly.
Because when exporting massive volumes of metric data to event hubs or log analytics, legacy systems would often just flatten the data to save bandwidth. But with DCRs, downstream analysis retains its original multi-dimensional granular detail, and it operates with an end-to-end latency of just 3 minutes.
Which is incredible.
Wow.
And Google Cloud is implementing a very similar philosophy on the storage side. Their Storage Insights datasets just hit general availability too. Cloud storage has historically relied on pretty static inventory management, but Google is shifting that to live dynamic behavioral analysis of unstructured data.
And that generates a query-ready index directly into BigQuery, doesn't it?
Yes, it does.
So for an architect trying to optimize costs or troubleshoot anomalies, the granularity is incredible. You aren't just looking at bucket-level activity logs anymore. You can see exact object-level actions. The report specifically highlights troubleshooting expensive 429 rate-limiting events. If an automated AI pipeline gets stuck in an expensive retry loop, just hammering a specific cloud storage bucket, you don't have to guess where the request spike is originating. You can trace that 429 event down to the exact object prefix.
Yeah, so we have autonomous agents running on highly observable, massive cloud infrastructure with mathematically proven silicon isolation. It is an incredibly robust ecosystem. But here is the problem. Threat actors have access to the exact same generative AI and automation technology.
Right. That's the terrifying part.
Yeah. We are now tasked with defending the automated enterprise against automated adversaries.
And the 2026 Darktrace Global Annual Threat Report makes it painfully clear that the fundamental nature of a security breach has changed. Identity compromise has entirely eclipsed pure vulnerability exploitation as the primary attack perimeter.
Because why spend weeks trying to hack a mathematically proven hypervisor when you can just log in using a stolen session token?
Yeah, exactly.
Threat actors are heavily abusing legitimate SaaS platforms and Microsoft 365 accounts. They live off the land, right? Using native administrative tools to move laterally and just bypass traditional network boundaries entirely.
And furthermore, when attackers do leverage software vulnerabilities, the speed of weaponization is staggering now. Common vulnerabilities and exposures, or CVEs, they are up 20% annually.
Live it, yeah.
And the time between a vulnerability being discovered and an exploit being automated by AI is shrinking to basically zero. Exploitation speed is vastly outpacing our ability to patch systems manually.
Right. Which is why Google Security Operations is essentially fighting fire with fire. They are deploying specialized AI security agents to counter this automated threat. Their detection engineering agent, which is currently in preview, continuously ingests global threat intelligence and autonomously writes and validates custom behavioral detection rules.
So instead of playing whack-a-mole with individual exploits, it's more like an immune system. Google's detection agent isn't just reacting to a known virus. It is autonomously generating the antibodies, the detection rules, before the automated exploit even enters the network bloodstream.
That's a really good analogy. And for the security alerts that do actually trigger, their triage and investigation agent is now generally available. It uses the Gemini model to autonomously analyze the telemetry of an alert.
And that's fast, right?
Unbelievably fast. It has cut manual investigation times from 30 minutes down to 60 seconds.
60 seconds, wow.
Yeah, a 60-second triage capability is critical to preventing alert fatigue in security operations centers. But technology alone cannot solve the sheer volume of threats. The regulatory framework governing federal and critical infrastructure has to adapt to this reality of infinite vulnerabilities.
And this brings us to a massive policy shift. CISA, the Cybersecurity and Infrastructure Security Agency, just released Binding Operational Directive 2604. We have officially abandoned the idea of patching everything. The strategy is now triage, not total defense.
Yeah, this directive officially revokes older blanket mandates like BOD 1902 and 2201. It institutes a very strict, risk-based approach to vulnerability management.
Okay, so how does that work in practice?
Well, organizations can no longer treat all vulnerabilities equally. You can't prioritize a low-impact internal bug simply because it is older than a critical external vulnerability.
Right. And CISA breaks the risk down into 4 dynamic variables, I believe. Public asset exposure, inclusion in CISA's known exploited vulnerabilities catalog, the exploit automation capabilities of the threat actor, and the level of technical impact to the organization.
Right. And if a vulnerability hits the high-risk criteria, say, for example, an automated exploit targeting a publicly exposed system in the KEV catalog that grants total administrative control, the mandate demands an aggressive 3-day remediation timeline.
3 days. That is aggressive.
It is. But more importantly, it requires mandatory forensic triage. You don't just apply the patch. You have to run forensic analysis to prove the automated adversary isn't already inside the network.
Yeah, it's a very pragmatic recognition that the automated threat landscape moves far too fast for traditional compliance checklists. We also have to examine how AI is being weaponized in the public sphere, though, beyond just corporate networks.
Yes. We need to look at the recent report published by OpenAI detailing PRC-linked influence operations targeting AI debates in the U.S.
And just to be perfectly clear for you listening at home, our goal here is to neutrally report the findings directly from the source material without taking any political sides. We are simply conveying the data and tactics that OpenAI published regarding these disrupted operations.
Absolutely. So according to the report, OpenAI disrupted 2 specific Chinese clusters that were utilizing ChatGPT to run covert influence campaigns. And these operations targeted U.S. technology policies, domestic infrastructure development, and corporate reputation.
And what makes these tactics so effective is that they do not rely on inventing fringe conspiracy theories.
Right.
They exploit and amplify legitimate pre-existing domestic debates. For example, the data center bandwagon campaign weaponized real-world concerns over rising utility costs. They generated massive volumes of content blaming local AI data center expansions for driving up electricity prices for families, and that masked the origin of the operation behind genuine local anxieties.
It's very clever.
Yeah.
And another operation, dubbed Tech and Tariffs, weaponized inauthentic social media accounts to spread fabricated claims that ChatGPT user data had been compromised.
Wow.
Yeah, it's a sophisticated combination of policy manipulation and corporate disinformation. It latches onto active political and economic issues to bypass basic critical thinking filters.
It just demonstrates how AI can be utilized to scale social engineering operations just as efficiently as it scales software engineering migrations. Which brings us to a pretty crucial reality check. We have these incredibly powerful autonomous systems actively transforming infrastructure and society, but are organizations actually ready to govern them?
Well, the short answer from the Avanti 2026 report is that there is a severe widening gap between deployment and governance.
I'm not surprised.
Yeah. While 56% of organizations are deploying AI at scale, 68% of IT professionals have observed AI hallucinations that directly impacted operations.
68%, that's a huge number.
Yeah.
And the most concerning statistic from the Avanti research is that only 42% report having clear accountability frameworks for AI decisions.
Only 42%.
Yeah. The report emphasizes that establishing a unified IT and security system of record is the absolute prerequisite for scaling AI safely. Because without a single source of truth, fragmented enterprise data severely limits model accuracy and operational reliability.
And the Cloud Security Alliance's 2026 Financial Services Report strongly echoes this governance gap, too. Autonomous AI agents are becoming mainstream in the financial sector, and AI-driven autonomous payments are expected to grow rapidly. However, sensitive data leakage remains their absolute top concern.
Right. And the CSA notes that emerging regulatory frameworks, specifically DORA and the EU AI Act, are completely reshaping how organizations must approach this governance, moving from voluntary best practices to strict, legally binding operational resilience standards.
So synthesizing everything from this deep dive, the technology stack has fundamentally evolved. We are no longer managing isolated tool sets. We are managing highly complex autonomous ecosystems.
Yeah, and that evolution requires smarter, mathematically proven silicon like Graviton 5 to prevent those cross-tenant breaches. It requires risk-based automated security models like CISA's new 3-day triage mandates and Google's 60-second Gemini investigations. And above all, it requires airtight, dynamically observable data governance. Now, if you want to stay ahead of these massive shifts, for more deep dives into cloud, security, and AI insights just like this, you should definitely follow the show Cloud and Cybersecurity News on Spotify.
But before we wrap up today, I want to leave you with a final concept to mull over, building directly on what we have explored today. The CSA report briefly touched on the concept of non-human identity governance.
No.
Consider what we have unpacked. Anthropic's agents generating and executing code independently. SQL MCP servers allowing AI to autonomously query proprietary enterprise databases, and CCOPS agents writing and launching security countermeasures in seconds. We're rapidly approaching a reality where non-human identities will outnumber human identities on corporate networks by a ratio of 100 to 1.
A 100 to 1 ratio of machines to humans operating on the network. That's intense.
It is. So here's the question for you to consider. When an autonomous agent makes a fractional second decision that cascades a critical error across a multi-cloud environment, taking down a core financial service or patient database, who is legally and operationally responsible? Is it the developer who engineered the agent, the cloud platform hosting the open-loop LLM, or the executive who initially approved the autonomous workflow?
It is a massive unresolved question. I mean, we started today talking about how AI is no longer just a train following a predefined track. It is an autonomous rover carving its own path through the enterprise. But when you give the rover a steering wheel, a map, and a mind of its own, you also have to figure out who pays the toll when it inevitably crashes. Thanks for joining us on this deep dive. We will see you next time.